In this tutorial, I'll be covering some methods for creating a custom projectile. If you have some experience and you need some help with something specific, here's a list of things I'll be covering in the video and their respective timestamps. These timestamps can be found in the description as well for those watching on mobile. Now let's create a projectile that fires once in a straight line and applies the hacked status, sort of like a sleep dart, but it hacks the enemy instead of putting them to sleep. I'll give it a cooldown as well. In order to create a projectile, we'll need to do a couple things to initialize it when the player joins the game. First, we'll need to set the projectile's position outside of the map, somewhere where no one will come near it. This is because being near the projectile is what we will use to detect if the player is hit by it. If we place it within the map to start, the player might run into it. Also, if we don't set its position will return as null, which will cause the game to think that the projectile is within the correct distance to register as a hit. So I'll make a rule that runs when the player joins the game. To keep track of the position of the projectile, let's save its position under player variable A, which I will rename to projectile position. And let's set that variable to a vector of 0, -50, and 0 to make sure that it's out of the way. After setting its position, we can create an effect at that position so we can see where the projectile is at. You can pick essentially any effect for your projectile, but I find that the orb works pretty well for projectiles. Create the effect and set its position to the projectile position variable that we just defined. Make sure that it reevaluates who it's visible to so that new players that join will be able to see it, and its position. So when we tell the projectile to move, the effect moves with it. We'll also rename player variable B to cooldown and player variable C to raycast position. And we'll set raycast position to a similar but different position than our projectile position, and I'll explain that later on. Since we're going to be using primary fire to fire this projectile, for this example I'm also going to disable primary fire for each player. So now we will program the projectile to fire when the player presses primary fire. Our conditions will check if the primary fire button is held, and if the cooldown is at 0. For our actions, we'll start by moving the projectile to the eye position of the player. Then we can use chase player variable at rate to move our projectile. I'm going to go on a quick tangent here to talk about chasing variables for those who are unfamiliar with it. Chasing variables causes the game to update a value continuously at a rate or over time. So given the context of our projectile, if we had it chase to a specific position, the game would calculate its new position every frame. You can also reevaluate where the goal position is, and the chase function will follow the moving goal position. If we use a rate, it will move at the same speed until it reaches the goal position, regardless of whether the goal moves or not. If we use a time, its speed will change if the goal position moves because it must reach its goal in the time specified. If the goal moves away from the projectile will move faster to cover that distance, and vice versa. Note that as of making this tutorial, you cannot chase a value in an array. You can only use a global or player variable that has one value saved in it, such as a position or a number. So let's get back to our projectile. We want this to fire in a straight line from the eye position of the player to the position they are looking at. We do not want the end position to move, so we will disable reevaluation. To get the position of where the player is looking, we will use a raycast. A good way of visualizing a raycast is thinking of Superman's laser eyes. It casts a ray in the specified direction over a specified distance and gives you the position that the ray hits first. On top of positions in the world, this can also include players or player turrets. For the starting position of the raycast, we'll use the eye position of the player. For the end position, we'll need to use some vector wizardry. We'll take the eye position of the player and add it to the product of the facing direction of the player times 100. Without the 100, the raycast would only extend out 1 meter from the player's face. Multiplying it by 100 extends the ray out 100 meters, essentially guaranteeing that the ray will hit some surface, since there aren't many open areas in Overwatch that reach over 100 meters. We want to exclude all players, since we don't want the goal position to be stuck where a player was when we fired the projectile. The rate you use can change based on how fast you want your projectile to travel. I'll set it to 50 for this demonstration. Now our projectile will fire and keep moving until it hits the target surface. Let's make it disappear though if it hits that surface. Right as we fire that projectile, let's also save that same raycast position under player variable C, which we renamed raycast position. And then, in another rule, let's check for if the projectile position equals the raycast position. That just means that your projectile hit the wall that it's traveling to. If this is met, then all we have to do is stop chasing player variable projectile position. That'll stop moving it, and then just set that projectile position back to 0, -50, 0. And now when we fire this projectile, it'll disappear once it hits the wall. After firing the projectile, we can set our cooldown variable to 1, and then add a wait for however long you want the cooldown to last. Let's say 5 seconds, and then we'll set the cooldown back to 0, and you'll be able to fire the projectile again. Now we can set up hit detection. For this, we will check the distance between the projectile and the target player. Obviously, every hero has a different hitbox, so you might want to go through and change the distances for every hero. As that sounds like an annoying amount of work, I'm just going to use 1 meter across the board for all heroes for this demonstration, and hope for the best. You're always free to adjust the numbers as you see fit. To be more accurate, you could also use an OR condition to detect if the projectile's distance was close to the player's position or their eye position, but for clarity's sake, for this demonstration, I'm just going to use the eye position. For hit detection in this example, I'm going to use 2 separate rules. One for the player who fired the projectile, and one for the player who gets hit by the projectile. So for this first one, I'm going to check for the player who fired the projectile. I'll call this projectile hit attacker. I'll start with a is true for any condition, and the array we're going to be checking is all living players on the opposite team of the team of event player. The condition that we're checking for here in this array is the distance between the eye position of the current array element, which in this case is all living players on the opposite team of the event player, and that projectile position variable. And we're checking to see if the distance between that and that is less than 1 meter. So once this becomes true, we'll just add a very small wait, and then we can take these same rules over here for resetting the position of the projectile, and then we can make our projectile hit for the victim. Now again, we'll use a isTrue for any rule, but this time our array will be the player variable of all players on the opposite team of the team of event player, and the player variable would be the projectile position. And again, we'll be testing for the distance between the I position of event player and the current array element. And in this case, the current array element will be any of the projectiles from the other team, and if the distance is less than 1. Now for this, we're also going to add 2 other conditions. First, we need to make sure that the position of the event player is not null. The position of the event player equals null for a short amount of time before the player spawns. Then also, we need to make sure that the number of players on the opposite team of the event player is greater than 0. This is just ensuring so that when we test the distance between these two things, one of them doesn't come up as null. Because remember, if you test for the distance between 2 objects and one of them is null, then the distance check will return as true and it will activate this whole thing. But that's why we have these 2 things in place, so that it doesn't run when one of them is null. So for our actions, we can create an effect to play when they are hit. I like to use the ring explosion. Again, this is up to you. So I'll have a ring explosion happen at the event player, and then I will also have a ring explosion sound at the event player. And then lastly, we'll just set the status of the event player to hacked for, let's say, 3 seconds. And that's it. The last thing I'll do here is create a HUD text visible to any player who has the player variable cooldown equals 0. And this way, people will be able to see when their projectile is ready to fire. So I've brought in my dummy bot here, and you can see in the top left corner my projectile is ready. So if I press primary fire, it hits Anna and applies that hack status, and you can see after 5 seconds my projectile is ready again. Now if I fire it and miss it, it'll hit this tree and disappear. And I'll have to wait 5 more seconds. And I can fire it again. And as long as it reaches a range within 1 meter of her head, then it should hit.
Damn.
Now there's a lot here to take in, so be sure to experiment with tweaking numbers and scripting. It really helps to see how things change as you change the numbers. If you're stuck or you have any questions, feel free to leave a comment and I'll help you as soon as I can. You can also check my other tutorial videos for more assistance, and you can always join my Discord full of other workshop players and creators and ask questions there, as well as find several game modes that I've worked on in the past. Thanks for watching.